Okay, on notes 8.5, we're going to be looking at more functions. Today we're going to be looking at exponential and logarithmic functions. So we've talked about those briefly before. Exponential, remember we had a growth or a decay, and then the inverse of an exponential was a log function. Okay, so our exponential parent function is 2 to the x power. Okay, so let's pick some values to plug in. If we plug in a -2, we would have 2 to the -2 power because x is part of your exponent on an exponential function. Okay, so we would have to move that in order to get rid of that negative exponent. So that would equal 1 over 2 squared, which would give us 1/4. If we plug in a -1, we would have to move that to make it a positive exponent. So that would be 1 over 2 to the first power, which would give us 1/2. If we plug in a 0, any base raised to the 0 power, remember, equals 1. That was one of our laws of exponents. If we plug in a 1, 2 to the first power, we get 2. We plug in a 2, 2 squared, we get 4. Okay, so those are the points that I'm going to be using for my parent function, f of x equals 2 to the x power. So -2 and then 1/4, -1/2, 0, 1, 1, 2, and 2, 4. Remember when we talked about exponential before, we have an asymptote, which means the line is approaching another line but never actually reaching it. So notice that this is approaching the x-axis there. Alright, we're going to look at the domain. The x-axis, notice it's continuous both ways. So the domain will be all real numbers. The range, however, if you look at the y-axis, it's all of your positive values. So it's everything greater than 0, but it doesn't include 0 because of that asymptote. Anytime you have an exponential function, you're going to have a horizontal asymptote. Okay? This case, it's at y equals 0. Alright, so that's our exponential parent function. The next one, notice we have a log function, f of x equals log base 2 of x, which is really the inverse of the exponential because the base is 2 to the x. So all I'm going to do here is I'm just going to flip my points from my exponential, because remember when you have an inverse graph, you're just reflecting those points across the line y equals x, which means you're just switching those x and y values. So I'm going to use the same ones that I was using on the exponential parent function. So this is the logarithmic parent function. So I'm flipping the point on the exponential, so 1/4 would be -2, 1/2 would be -1, 1, 0, 2, 1, and 4, 2. Alright, so I'm going to plot those points. 1/4, -2, 1/2, -1, 2, 1. I just plotted. So go back to 2, 1, and then. Hang on, I'm going to start over. Alright, 1/4, -2, 1/2, -1, I skipped over 1, 1, 0, 2, 1, and 4, 2. So notice this time that this is approaching the y-axis, so you have a vertical asymptote whenever you have a log function. You're going to need to know that. So exponential is approaching the horizontal asymptote, and then your log function is approaching the vertical. So notice the domain. Look at the x-axis. It's only using positive values. So x is going to be greater than 0, but doesn't include 0 because that's our vertical asymptote. the range. Notice it's continuous both ways on the y, so that will be all real numbers. And then on a log function, you have a vertical asymptote. Notice that that's crosses the x at 0. These are going to match. Look back up at the top. So on your exponential, your range and your horizontal asymptote will match. And then on your log, your domain and your vertical asymptotes will match. Just one will be equal to. Alright, so those are our two parent functions. You will need to transfer those to your yellow parent function chart. Okay, so look at 3. You have to determine if it's exponential or log. An exponential function has x in the exponent. So notice this is exponential. It gives us our parent function here, 2 to the x. So let's go ahead and fill that chart in from the top. So -2 we plugged in and we got a fourth. -1 would be a half. 0, 1, 1, 2, and 2, 4. So those are our parent function values. Now let's write our transformations down. So our base of our parent function is 2. So that is a base, but this one is a coefficient. So if our coefficient is 2, that's going to be a stretch by 2. Notice on the outside of parentheses we have +1, so that's going to shift it up 1. Now, on the other functions that we've looked at this unit, we were shifting the 0, 0, which was the origin point. But notice we don't have a 0, 0 point. But I still want you to go ahead and shift the origin. So I'm going to use a different color for my origin. I'm going to say blue is my origin. So I need to shift it up 1. So there's my new origin. That's not going to be a point on your graph. That's just my new origin. Okay? So we went up 1. Now we need to stretch by 2. If you remember a stretch and a shrink, we're having to multiply that number by your original y value. So I'm having to multiply by 2, which would give you a half. Multiply by 2, which would give you 1. That would give you 2, 4, and 8. So we're using our new origin and we're plotting these points here in our table. So I'm going to do -2, a half. So left 2, up a half. -1, 1. 0, 2. So we're plotting from that blue point that I have. 1, 4, because that's my new origin. 2, 8. Remember we talked about on exponential it should be approaching a horizontal line, and we're going to go ahead and draw that. It should go through that blue point that we plotted, the new origin. Alright, so your domain, continuous both ways, so that would be all real numbers. Your range, if you look at the y-axis, it's only using values above 1. So y is greater than 1. It doesn't include 1 because that's going to be where our horizontal asymptote is. So that would be crosses the y at +1. So y equals 1. So you're still shifting your origin like we did in the past. So we're shifting that, and then we're plotting our points. Okay, let's look at 4. Notice again we have exponential, because x is in the exponent. Here's our parent function. So -2 would be 1/4, -1 would be 1/2, 0, 1, 1, 2, and 2, 4. Okay, let's write our transformations down. Here's our parent function, and we're going to this one. Notice there's a negative in front, so that will reflect. Notice inside the exponent position, it's x + 3. Anytime it's with x, that's a horizontal shift. X + 3 would mean it's going to the left 3, and then the -5 after the exponent means you're going down 5. Okay, so again, we're going to shift our origin. We need to shift left 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. There's my new origin. So that blue point is my origin. So we shifted. Now we need to reflect. Remember we talked about on the reflection, we're changing the sign of each original y value. So now it's a negative 1/4, negative 1/2, negative 1, negative 2, and negative 4. So we're having to change the sign of each one. Alright, so now I'm looking at that blue point, that's my new origin, and I'm plotting the points from our table. So left 2, down 1/4, left 1, down 1/2, and then 0, so we're not moving, but we're going down 1, 0, negative 1, and then 1, negative 2, so right 1, down 2, and right 2, down 4. It's exponential, so remember it's approaching that horizontal line. So there's our horizontal asymptote. It should go through that origin point that we shifted. Anytime it's a negative in front, it should be decreasing from left to right. So make sure you're checking that. If it's a negative in front, whether it be exponential or log, it should be decreasing from left to right. All right, your domain. Notice it's continuous both ways. So your domain of any exponential that we're looking at is going to be all real numbers every time. Your range, if you look at the y-axis, it's everything below 1, 2, 3, 4, 5. So y is going to be less than negative 5. We have a horizontal asymptote at y equals negative 5. Okay, notice 5, we have our log function. So our log parent function is log base 2 of x. So I'm going to fill in the table from our parent function on the front. That was number 2. So we have 1/4, negative 2, 1/2, negative 1, 1, 0, 2, 1, and 4, 2. Okay, let's write down our transformations. So the negative in front will reflect. Inside parentheses here, that's a horizontal shift. It says x minus 1, which means you're going to go to the right 1. And then the plus 2 on the outside means you're going to go up 2. Same thing as our exponential function, we're going to shift our origin. So I'm going to go right 1, up 2. Here's my new origin. So we did both of those, now we need to reflect. So we're changing the sign of each one, so that will become a positive 2, positive 1, the 0 doesn't change, negative 1, and negative 2. Alright, so the blue point is my new origin. I'm plotting the points 1/4, so right 1/4, up 2. And then right 1/2, up 1. 1, 0, so right 1. And then right 2, down 1. And right 4 from that blue origin point, down 2. Remember, on a log function, it should be approaching a vertical asymptote. We can go ahead and draw that. We know it's going through that new origin that we found, the blue point. Notice that this line is decreasing from left to right because it was a negative in front. Alright, your domain, if you look at your x-axis, it's only including x values greater than 1. So x is greater than 1. If you look at the y-axis, it's continuous both ways, so all real for your range. So any of your log functions, it's going to be all real. And then we're going to have a vertical in your log functions. your vertical is crossing the x at 1. So x equals 1. Okay, I'm going to write down your transformations, and then I want you to try number 6 on your own. So you're going to have a stretch by 2. And then the plus 3, notice there's not parentheses, so that's going to be going up 3. So you will have to shift your origin up 3, and then you'll have to stretch your original y values by 2. So I want you to try that one on your own. You can press pause and then come back to it. Alright, let's look at the next page. We're going to write the equation of each of the following. So make sure that you're paying close attention to what type of function you're starting with. We're starting with a log function. Our log parent function is log base 2 of x. That base should never change. We're going to shift to the left 3 and up 2. Make sure you're writing either f of x or g of x equals function notation. We're going left 3, so I have log. My base is still 2. If we're going left, we need parentheses around the x, and it should be plus. Close your parentheses. We're going up 2, so on the outside of the parentheses, you should have plus 2. On 8, we have exponential, because we have x as part of the exponent. The base is 2. We're going to shift left 1, down 7, and shrink by a factor of 0.5. That means my coefficient in front is going to be either 0.5 or a half, same thing. My base of my exponential is 2, and then my exponent is x. But I'm having to go to the left 1. So in the exponent position with your x, you need to be adding 1. Make sure that plus 1 is in the exponent. Down 7 means after your exponent, you should be subtracting 7. Okay, 9, log function, we're reflecting, stretching by a factor of 5. So reflection is the negative, you're stretching by 5, so that's the coefficient. And we're not shifting left, right, or up or down, so we're just writing log base 2 of x there. Alright, the next part, we're looking at graphs. This is the hardest part of this, so make sure you're paying attention. Okay, so we're going to have log and exponential. You have to determine which one you have, so that way you know what type of equation or function you're going to have. Okay, so remember I told you on the front, anytime you have a horizontal asymptote, we know that it's exponential. Anytime we have a vertical asymptote, we know that it's log. So you have to figure that out at the beginning. So let's find our asymptote. So notice this line here is approaching this vertical asymptote. So if we have a vertical asymptote at x equals 0, we know that we have a log function. Okay, because it's vertical. Go ahead and write log base 2 of x. That's my parent function, and I'm going to adjust it. Okay. Notice that we're not shifting left or right because our vertical asymptote did not change, so we should not have parentheses on this one. What I want you to look at is on your log parent function. Oops, I don't want to write log again. Let's look at our 1, 0 point. So what I want you to do on these is I want you to plot 1, 0. Now, we know it didn't shift left or right because of our vertical asymptote. It stayed at the same spot. So what do we need to do to this point to get to go up or down? We need to go up 3. Okay, so if we're going up 3, that means we would need to add 3. On the outside, we don't need parentheses there. How you know if it's a reflection you're looking from left to right. So from left to right, notice this is going down. That would mean there is a reflection. That means there's a negative in front. So we have our parent function, there's a reflection, and it went up 3. We know it didn't go left or right because our vertical asymptote stayed at the same spot. Okay, let's look at 11. So notice, let's find our asymptote. Notice it's approaching a horizontal. It's crossing the y at -3. So this means we have an exponential. So my parent function of exponential is 2 to the x. Alright, now look at your asymptote. It's normally at 0, y equals 0, but it's now at -3, which means it went down 3, because it's normally at 0. Now what I want you to do on the exponential, I want you to look at, we don't have a 1, 0 point, we have a 0, 1 point. So go ahead and plot that 0, 1 point. And we know that point went down 3. 1, 2, 3, which would be this point here. Now, what do I need to do to that last point that I plotted in order to get to the next one? We have to figure out if we're going left or if we're going right. We already know where we shifted vertically. So notice we're going to the right 3 to get to that next point. So we went down 3, which would be -3 on the outside. We went right 3, which would be minus with your x. So it should be 2 to the x minus 3, and then -3. So there's several different things you're having to check. Also check for your reflection. It's increasing from left to right, so there's no reflection. So you're having to check to see if it's log or exponential. Then you're having to check to see where it shifted based on your asymptote. Then you need to check either your 1, 0 point for log or your 0, 1 point for exponential. Alright, number 12. Notice it's approaching this horizontal line here. So if it's a horizontal asymptote, that would be y, 1, 2, 3, 4, 5. That means it's exponential. So our parent function is 2 to the x power. Alright, we know that from our asymptote, it's normally at 0. It went up 5. So I want you to look at your 0, 1 point. Now, the thing is, you have to also look at your reflection. Notice from left to right that it's decreasing, so it was reflected. Which means that would change your 0, 1 point to 0, -1, because you're changing the sign. So we would need to plot our 0, -1 point, which is here. We know it's going up 5, 1, 2, 3, 4, 5, which would be here. So what do we need to do to that point in order to get to the next one? So you would have to go left 2. So we're reflecting, so that's the negative because it's decreasing from left to right. We're going left 2, which would be x plus 2 in the exponent, and then up 5 would be a plus 5. Alright, last one. Okay, so checking for horizontal vertical. Notice that there is a vertical here. Looks like it's staying in one spot there. It's just getting closer and closer to that vertical. So vertical asymptote would be at x equals 1, 2, 3, 4, 5, 6, 7, -7. Since we know there's a vertical, we know it's log. So I'm going to go ahead and write the parent function, log base 2 of x. Notice from left to right it's increasing, so we know there's no reflection. I'm going to check my 1, 0 point. So plot 1, 0. We know that from our vertical asymptote, it went to the left 7. So go ahead and shift that 1, 0 point. 1, 2, 3, 4, 5, 6, 7, which would be here. So notice you're going to have to go down 2 to get to that next point. So left 7 means we're going to have an x plus 7 in parentheses. And then down 2, we're going to have a minus 2 on the outside. So you're having to check for several different things on that. First thing, check to see what type of asymptote you have. That determines if it's log or exponential. Then you can check for your reflection by looking from left to right. And then at the end, you're checking your either 0, 1 point or 1, 0 point based on log or exponential.